So problem 22 says to finance the $15,000 cost of their kitchen remodeling, the Chews will make equal payments at the end of each month for 36 months, and they'll pay interest at the rate of 7.2% compounded monthly. And we need to find the amount of each payment. So for that, we're going to use the TVM solver because this is a finance problem. So they're going to finance this amount. This is the amount that they're going to borrow. Apparently that pen's back had it. And they're going to make 36 payments, which means it's 3 years at 12 payments a year. And their rate of interest is 7.2% compounded monthly, and we need the payment. So we get the TVM solver. And it says that they're going to make 36 payments, so the number of payments is 36. The interest rate is 7.2%. The present value of the loan is the actual amount that they're borrowing, and since that money is coming to them, that's cash inflow. But it really won't make any difference. It's going to tell us the payment is a negative amount because that's cash outflow. So we're going to solve for the payment amount. And the future value, of course, they want to be 0 because they want the loan to be paid off. And then 12 payments per year and 12 compoundings per year. And it says at the end of the month, so we're going to leave that payment at the bottom is going to be end instead of beginning. So the first thing we're going to do is we're going to copy down what you put in TVM solver. I did not put these on the final exam, so I'll give you a sheet if you want it, or you can just draw your screen. But be sure and tell me what you put into the TVM solver. So 36 payments, 7.2%. The present value is the $15,000. The payment is what we're going to solve for. The future value they want to be 0 because they want to pay the payment off. And both C/Y and P/Y are equal to 12. Payment is made at the end.
I got confused and was thinking the future value, that it was sort of like a sinking fund, so 15,000 was the future value. So I just mixed them up.
Okay, and I can see why you might have thought that, but if they're going to finance that cost, then they don't need to set up a sinking fund.
Okay.
What they're doing with the sinking fund is saving
Okay, that's
to pay
what
for
I was sort
it
of
all at
thinking.
once. Okay? So then we'll solve for the payment amount. And the payment amount is $464.53. I'm sorry, 53. Yeah, 53 cents. Okay? I'm gonna leave that there for a minute, because some people are still filling in their notes, but we're gonna next do problem number 21. So I'll go through and mark what we know about 21. It says, Shalon Bridges deposits semi-annual payments, so that's twice a year, and those payment amounts are $3,200, so that's going to be cash outflow. And this is money that he received in payment of a debt at an ordinary annuity. And an ordinary annuity, the payments are made at the end. At 6.8% compounded semi-annually. Since he's making semi-annual payments and it's compounded semi-annually, that just means C/Y and P/Y are both going to be 2. And of course your interest rate there is 6.8%. And it says find the final amount on the account and the interest earned at the end of 3.5 years. So N is going to be 3.5 years times twice a year. So that means N is actually going to be 7. Okay? So we'll go to the TDM solver again. And 3.5 times 2 will give us the 7. The interest rate is 6.8%.
And somehow come up wrong up there.
Oh, what did I do? My goodness. Yeah, okay, thank you. I don't know what I put in, but thank you for catching that. The present value of the loan is of no interest to us because they want the final amount that's in the account. So actually, Angelique, this is a sinking fund. Okay, this actually is. We didn't call it that, but it's a sinking fund.
On the final, will you want us to know if the problem's a sinking fund or not?
Well, no, you just need to know how to work it.
Okay.
This is a type of a sinking fund.
But we don't need to know that.
You don't necessarily need to know that, no. So your payment amounts are cash outflow, so they're negative, and it's $3,200 per payment. The future value is what we want to solve for. P/Y is 2, and C/Y is also 2. And because it's an ordinary annuity, the payments, as we said, are going to be at the end. And we're going to solve for the future value. So at the end of the 3.5 years, Mr. Bridges is going to have $24,818 and 76 cents. Now, of that amount, he paid in $3,200 7 times. So he paid in $22,400. So that means that the amount of interest that he earned and somehow I got an extra 2 in there. He earned $2,418.76 interest. Okay. So that's 21. And now we'll look at problem number 20. Problem 20 says a firm of attorneys deposits $1,500. That's going to be a negative $1,500 because they're paying it in. A profit sharing money in an account that is paying 6% compounded semi-annually for 7.5 years. They want to know, this problem says find the amount of interest earned. So the TVM solver is going to need the information. So for the number of payments, he's making 7.5 years, or they're making 7.5 years worth of payments, and they're paying twice a year, so that's going to be times 2. The interest rate is 6%. The present value is not something we're interested in. Their payment amount is $15,000. We are interested in the future value, and since this is still semi-annually, we'll leave that where it is and solve for the future value.
Miss Lynn,
Mm-hmm.
when it's a deposit, wouldn't it be a negative 15 in the present value unless
No,
it says each month it would go into the payment?
Yes, you are right. I misread the problem, so thank you. Because it doesn't say they're making $15,000 a month, they're making $15,000 one time.
Yeah, so that's the initial deposit.
So that is the initial and only deposit. There are no payments. So thank you. So then we will go down and solve for the future value. So the future value is $23,369.51. And even though there were no payments, we'll just leave payment at the end. So then the answer to the question, it says how much interest was earned. Well, the amount of interest that was earned was the future value, which is 23,369.51, minus the amount they actually deposited, which was 15,000. So the amount of interest is going to be $8,369.51.
So if it's not a payment, you don't have to multiply it by whatever it is.
Right, because they only put in that one time, they put in that total amount of money.
So if it was a payment, you would multiply it by.
Yeah, if it had been payments, we would have done what we did in the last problem. But they only made one payment. Okay, is everybody good on that one? Okay. Number 19, find the monthly house payment for a $56,890 mortgage at 6.74% for 25 years. And the formula's right there for you to be able to use that, but you don't necessarily have to. You can still use TBN solver. So this is going to be a mortgage problem because we're finding a monthly house payment. The present value is the $56,890 mortgage. The payment is what we're going to find. So we're going to set it equal to 0 and solve. The future value is going to be 0 because we want the house to be paid off. The payments per year, since it's monthly, is 12. And compoundings per year is going to match that, so that's also 12. And we're going to make the payments, when you're making house payments or mortgage payments or whatever else it is, those payments are always made at the end of each period. So N is going to be 25 years times 12 payments a year. And the interest rate is 6.74. Actually, it's not negative because they're actually getting the money. It's cash inflow. They're just having to turn around and pay for the house.
Does that make a difference? Because I put negative.
It won't make any difference because the payment amount's going to come out to be negative anyway.
Okay.
So their house payments are going to be $392.70.
would you times 25 by 12 to get to 300?
Yes. Okay? Now, if they wanted to know how much total interest was paid on the house, then you would multiply the payment amount by the 300 payments, and then subtract off the actual amount that they borrowed, and all the rest of it would have been interest. Okay?
Will that be a bonus question?
I don't think there are any bonus questions on the final exam.
Okay.
I don't remember it. That was just actually a reminder that, you know, if you were asked a similar question, it might ask you the same kind of questions that have been on other exams. Okay, so for number 18,
You said the final will be very similar to the.
yes,
So you got.
it will be shorter, but it is similar. Okay, problem 18 says, find the amount of payment necessary to amortize a loan of $32,000 at 8.4% compounded quarterly for 10 quarterly payments. Now you have to read that carefully because this tells you how many payments you're going to make. So you're not going to multiply that by anything. Okay? It gives you the total number of the payments. And your loan is $32,000, so that's going to be, you can put it in as a negative, but it's still going to come back and give you the payment amount as negative, whether you do or not. And 8.4% is your interest rate. And compounded quarterly tells you that C/Y and P/Y are both going to be 4, even though that has no impact on the payments. So we'll feed all the information to the TVM solver.
So it doesn't matter if 32,000 is negative or not?
It won't make any difference if it's positive or negative because they know the payment amounts are going to be negative because the future value is 0.
Miss Lynn, your 12 is before, doesn't it?
Hmm?
Your PY, CY, doesn't need before.
Yeah, I'm putting those all in right now. So,
But if you were trying to find like the future value, it would matter if it was negative or not.
yes.
Okay.
Although, remember, future value, payments, and present value always have an opposite sign from the future value. Okay? And, you know, if you get a negative amount for the future value, you think, well, okay, that just means I forgot to put my negatives in for the other part. So we will solve for the payment amount. And the amount of the payments is $3,581.11. So they will pay those payments 10 times, which means they'll be paying $35,811.10 total to repay their $32,000 loan. Okay? Number 17 says find the present value of an ordinary annuity. And the ordinary annuity means that your payments are going to be made at the end of each payment period. And the payments are $4,210 each. They're made semi-annually, so twice a year, for 8 years. So N is going to be 8 times 2, which is going to be 16, at 5.6% compounded semi-annually, so of course these have to match. So we're going to solve for the present value. And the payment amounts are $42.10. The future value we're not interested in, so we're just going to leave it as 0. P/Y and C/Y are both going to be 2. And the payments are made at the end. So at the end of the 16 payments, the present value that they could have deposited one time, that's basically what this is asking you, how much could they have deposited one time and had the same amount of money that they would have had they made those payments over time. So their one-time payment could have been $53,000. $699.94. They would have had the same future value if they had deposited that at the same interest rate and only made one lump sum deposit. And yes, these formulas, sometimes they are given on the final exam. And I do give you a formula sheet. This is a big clue on this particular problem because it's telling you, find the future value of an annuity if $1,288 is deposited at the end of each year for 14 years. And it earns 7% compounded annually. Now we can still use the TVN solver because it's still an annuity. It is an ordinary annuity because your payments are made at the end. Your payment amounts are $12.88. We're not interested in the present value. Interest rate is 7%. And it's compounded annually, and you're paying at the end of each year for 7 years, so that's going to be 7.
14 years.
I'm sorry. Don't know why I said 7. Thank you. And then your payments per year are once a year and compounded once a year because it's compounded annually. And we want to know the future value. So if they deposit $12.88 per year for 14 years at that interest rate, they're going to wind up having $29,045.03. Okay? Any questions so far? We've only got 1, 2, 3, 4, 5 problems left. Although I will go back over, I'll go all the way back to the beginning for as long as we need to study.
Would you be willing to go over the back part of the study guide again, over number the 29 through 20, like, I think it was 4 again, at the end?
We could, but there's already a recording of those.
I'll just work it for you.
Okay. Number 15 says find the present value of $1347.89 in 3.5 years at 6.2% compounded semi-annually. So the compounded semi-annually is twice a year for 3.5 years. So that's going to be 7. We'll solve for the present value. The interest rate is 6.2. There are no payments. And the future value is $1347.89. And since it's semi-annual, that's twice a year. So the present value is $1,088.54. Okay?
Why are we going backwards?
Because that's how I started it out.
Okay, I was just wondering.
I was trying to make sure it makes more sense to go forward, except I've already got the first 10 worked, and I've already got 22 through the others worked. And since that one was working backwards, I just continued to work backwards.
Okay, sorry.
So we need to find the amount of compound interest earned by depositing $2,975 at 4.7% compounded monthly for 4 years. So compounded monthly for 4 years, that's 4 years times 12 payments a year at 4.7% interest. And the present value is not anything we're interested in because we're not making a lump sum deposit, we're making payments. So the payment amounts are $29.75.
Is that payments or is that one lump sum? Because it says it's just depositing and it's compounded monthly.
Let me read again. No, that is a lump sum, so you're right. And it's still negative. Yes, I know you didn't like that one. And in order to find the amount of interest earned, we're going to have to find the future value. So we're going to solve for the future value. And compounded monthly is going to be 12 for C/Y and P/Y. So there's our one-time deposit, and we need the future value. So the future value is $3,589.01. And since we initially deposited $2,975, then $614.01 was the amount of interest. Okay? Any questions? Okay, let's go to number 13. Says find the compound amount and the amount of interest earned for $57,809.34 at 4% compounded quarterly for 6 years. So that is actually then the present value because there was no payment mentioned. So this is your present value. And in order to find the compound amount is the same thing as the future value. So 6 years worth of payments, compounded quarterly, means then it's going to be 24. And P/Y and C/Y are both 4. And it doesn't matter about the payment because we're not making any payments. And the interest rate is 4%. So the future value is going to be $73,402.52. And the amount of interest earned is the difference in that and the initial deposit. So the interest earned was $15,593.80. We are ready now for number 12. We'll do it one part at a time. Part A says find the simple interest. When it says simple interest, you know that means interest equals principal times rate times time. And the time has to be in years and the rate has to be a decimal. So, principal in this case is $4,902. The interest rate is going to be 0.065, and 11 months tells you that the time
It's 11/2.
is going to be 11/12 because there's 12 months in a year.
12. Sorry.
That's okay.
So we can't put this into our TD and stuff.
No, not simple interest. Simple interest, you have to do the formula.
And it's principal times rate times time.
Yes. So we'll put that into the calculator. The interest earned is $292.08. Okay? And then it's going to be the same formula for the second problem. So for part B, the only thing we're going to change are the principal amounts. The interest rate is 0.074, and the time says 88 days. So that's 88 days out of 365 days in a year. So the amount of interest is going to be $62.05.
Not much interest.
Well, 88 days isn't very long.
Oh,
No, it's not even 3 months.
It's a decent amount of money for not doing anything with it besides just sitting away from the bank.
Yeah, it's a pretty decent rate of return for doing nothing.
So my house built 3 months for $60. That's not my house.
Miss Flint?
Mm-hmm.
I think I did this wrong. I did that, but I got my decimal in a different place.
For which one?
For part A, I got 29207.75. Is it? I got my decimal. I got the right answer, but I got the decimal in a different.
It has to be .065.
Oh, six.
Yeah, that's why your decimal was off. Remember that when you're putting in your interest rate, that you're having to move the decimal 2 places to the left. So that means you're going to need to insert a 0 in front of that number. Okay? Okay. Problem number 11. And if I remember right, this is one of, look to see, this is one of 3 problems out of chapter 3. Company makes 2 kinds of pizza, special and basic. Cost of the vegetables is $2 a unit for the special and $1 a unit for the basic. No more than $30 per day can be spent on vegetables. The cheese used for the special is $5 a unit, and the cheese used for the basic is $4 a unit. They can't spend more than $100 a day on cheese. How many units of each kind of pizza should the company make in order to maximize revenue if the special pizza sells for $2 per unit and basic sells for $18 per unit? Okay, I'm going to work backwards a little bit. We're wanting to maximize revenue. Revenue is going to be $20 times the special, which we're going to call X, plus $18 for the basic, which we're going to call Y. And we need to write a system of inequalities that describes the situation to be able to do that. Because what we're going to do is we want to maximize that revenue. So I'm going to go one sentence at a time and pick out the information with you. The cost of the vegetables. $2 per unit for the special. That's 2x. $1 per unit for the basic. And they only have $30 a day to spend. So that 2x plus 1y has to be equal to or less than 30. Next sentence says cheese. So for the cheese, $5 a unit on the special, that'd be 5 times x. Basic is 4 times x, or 4 times y, I'm sorry, not x, y. And the total amount they can spend on cheese is $100. So now we need to figure out how many pizzas they need to make. So what we're going to do is we're going to graph 2x plus 1y is equal to or less than 30. And if we let x be 0, that means in the related equation, if we let x be 0, then y is going to be 30. And that gives us the point 0, 30. Then if we let y be 0, then 2x is going to be 30. And x is going to be 15. So that's the point 15, 0. So there's our 2 points. And we only need to be in the first quadrant. Because they can't make negative pizzas. So our last restrictions here are that x has to be equal to or greater than 0 and y has to be equal to or greater than 0. So we've taken care of that just by drawing the graph. And it says use a scale of 5 on the x and y axis. So that means for this one, the point 0, 30, 5, 10, 15, 20, 25, 30 is right there. And then 5, 10, 15 would be right there. So there's our vegetable equation. And then for the cheese equation, (5x plus 4y equals 0) says that if x or equals 100, I'm sorry, not 0. That'd be fun. If we let x be 0, then 4y is 100 and y would be 25. And if we let y be 0, then 5x equals 100 and x would be 20. So there's our 2 points for that. So 20, 0 would be right here. And 0, 25 would be right here. So there's our cheese equation. And we need to check and see which way we shade. So we let x and y both be 0 and say is 0 equal to or less than 30. And yes, it is. That tells us we're going to shade this direction. And then same thing here. Is 0 equal to or less than 100? Of course, that's true too. So we'll shade below both lines, which tells me that the area that is the feasible region is right here. So you can either solve the system of equations to find the other corner point, which is going to be this one, or you can graph and find the intersection point, whichever one you want to do. I personally think it's probably easier to just do the matrices. So the system of equations to find the corner points that you would use, the matrix that you would use, would be 2, 1, 30, and 5, 4, 100. And then we would need the reduced row echelon form of that matrix. So we'll go to the matrix function and edit matrix A, which is a 2 by 3, 2, 1, 30, and 5, 4, 100. So what we need to do is go over to the math menu on the matrix, down to RREF, and we use matrix A. And since it came out to be decimals, I'll ask you to change that into a fraction. And it says the intersection point is 20 over 3 and 50 over 3, or that x is going to be 6 2/3, which we're going to have to call, we'll just call it 6.7, and 16 2/3, which we're going to call 16.7. But then we have to talk realistically, can they make 2/3 of the pizza and sell it?
No.
No. So what they actually are going to have to do is they're either going to make 6, 16, or they're going to make 7, 17.
They won't have the resources to do a 7, 17.
That's right. That was going to be my point. So that's very observant. They really, realistically can't do that one because that point would be outside of the feasible region. They won't have enough resources, so we can't round up. So that means that that corner point is going to have to be 6, 16. And then the other corner points are going to be the 0, 25, and the 15, 0. So keep in mind that you are not going to use this point or this point. Those are not corner points. They're not part of the feasible region. And you're not going to use 0, 0 because that means they make no revenue. So you know that answer makes no sense. So then we're going to plug into the revenue equation that we came up with. The revenue for XY was 20X plus 18Y. So we have 20 times 6 plus 18 times 16, or 20 times 0 plus 25 times, 18 times 25, although it wouldn't make any difference. Or 15 times 20 plus 18 times 0. So for the first option, they would make $426.
Wouldn't it be 16 instead of 17?
Ah, yes. So $408 from that situation. Or 18 times 25 is $450. Whereas 20 times 15 is only $300. So their best option then is to make basic pizzas and quit selling the specials. Okay? Okay?
Will you scoot that over a little bit? Thank you.
Now the tricky thing here would have been if you hadn't realized that you couldn't round those up. But you still make less revenue even if you do. Okay? Even if you did round them up, you make less revenue.
So if it was like, the 20 and 0,
Mm-hmm.
or not the 20 and 0, the 15 and 0,
Mm-hmm.
it would be the specials.
Yes.
So if it's on your, if you're
This is all basic. And this is all specials.
for the top will be both.
And the top ones where you're making a few specials and more basics. Now honestly, if these are smart business people and they're looking at this, what their brain should be telling them is they're not charging enough for the special pizzas. If they're going to keep making those pizzas with those ingredients at that price, they need to raise their prices. Okay? So that's number 11. And since we do have some time left, and I know that chapter 3 was probably the most challenging for most of you. I'm gonna go back over problem number 10 and problem number 9 again, and then I'll go to the end with the time you've got left and look at the one that you wanted to look at, okay? So in problem number 10, we have an office supply manufacturer makes two kinds of paper clips. Standard, which we're going to call X, and extra large, which we're going to call Y. And to make standard paper clips requires a quarter of an hour on a cutting machine. And that would be more easily written as 0.25, since it actually comes out to a nice fraction. And a half hour on a machine that shapes the clips, which we'll also use 0.5 for that because that one comes out nicely. So 0.5y. I'm sorry, I just totally blew that one. Let me back up, because I wasn't thinking about not talking about the basic one yet. Okay, we have cutting machines, and we're going to have shaping machines. So the standard ones, which is the X, takes a quarter, and realizing now that I've got a third of an hour, I think we're going to have to stick with fractions here. So 1/4 times X and 1/2 times X were the two times. And then making 1,000 extra large paper clips takes a third of an hour on the cutting machine and a third of an hour on the shaping machine. He has 4 hours a day available on the cutting machine and 6 hours a day available on the shaping. It says shipping, but that's supposed to say shaping. So there's your system of equations. And of course, X greater than 0 and Y greater than 0 has to be part of that because you can't make negatives. So there's your system of inequalities. The matrix that's going to go with this, because it says how many of each can he make, so we're just looking for a solution. So the matrix that goes with this is going to be 1/4, 1/3, 1/2, whoops, 1/2, 1/3, and then the last column is going to be 4/6. So there's matrix A. And then we're going to need the reduced row echelon form of matrix A to get the solution. So again, that's going to be a 2x3. So we enter the values into the matrix, and it does change those into decimals, but it'll still work. So we go over to math on the matrix menu, go to RREF for matrix A, and the resulting reduced row echelon matrix is 108 and 016 tells you this is the value of X and this is the value of Y that solves the equation. And even though the solution is 8,6 as an ordered pair, you need to explain what that means. Manufacturer can make 8,000, okay, because remember it's coming up in thousands. So they can make 8,000 of the standard. And 6,000 of the extra large. Okay? Any questions on that one?
Just a second.
Yeah, I was just pulling it down so that you could see everything. Make sure that you realize this is 1/2 because I kind of messed that up.
Thank you.
Okay. So looking at problem number 9, similar problem. Social service agency provides counseling, meals, and shelter to clients. And they're referred by sources 1, 2, and 3. The clients from source 1 take $100 for food. So that tells us that the clients from source 1 are going to be X. And source 2 then is going to be Y. And then source 3 is going to be Z. And then we're going to have 3 equations. One of the equations is going to be about counseling. So for counseling, source 1 takes $100, or no counseling, so 0 for counseling.
Does it matter how I put the counseling, food, and shelter?
No.
It just matters the group 1, 2, and 3.
Yes, you have to identify that they are the variables. How many?
The counseling and others.
Yeah.
Okay.
And then source 2 clients need 100 for counseling. And source 3 clients need 100 for counseling. And they have funding at most for $25,000 for counseling. So that gives you the equation 0x plus 100y plus 100z is going to be equal to or less than, I'm just going to move the calculator out of the way for a minute, is going to be equal to or less than the $25,000. Then we're going to have another equation about food. So the source 1 people need $100 for food. Source 2 need $200 for food. And source 3 need $150. And the most they have to spend on food is $50,000. And then the last thing is shelter. So a source 1 client needs $250 for shelter. Source 2 don't need anything for shelter, so apparently they've got a place to stay. And source 3 need $200 for shelter. And the most they had to spend on shelter is $32,500. So that tells us that this is what our matrix A is going to look like, because that's our system of inequalities. So matrix A is going to be 0, 100, 250 for the first row, 100, 200, 0 for the second row, 100, 150, 200 for the third row, and then the third column. I keep saying row, but that's column. And 25,000 for the last column, 50,000, and 320 or 32,500. And then we're going to have to get the reduced row echelon form of that. So this time we have a 3 by 4 with the entries 0, 100, 100, 25,000, 100, 200, 150, 50,000, 250, 0, 200, 32,500. So the reduced row echelon form of that is 1's on the diagonal, 0's everywhere else, and the last column tells us the solution. So the solution in a sentence the agency can serve 50 source 1 clients, $150 source 2 clients, and 100 source 3 clients.
Is there supposed to be a line on A between the 100, 150, 200?
There?
Okay, yeah. so-
Yeah, there can be. The calculator doesn't show it, but you can put that line there because that shows it's an augmented matrix.
Okay, thank you.
Okay? So we need, what we're going to do now is we're going to go back toward the other end. And which ones in particular did you want to see?
Could you go over number 29 and 28 again?
28, 29.
I didn't do one that you.
Okay.
I mean, unless there's something that someone else needs to see, because like you said, those don't know if you don't.
Well, the others are worked out on the video too, so.
Can I see that last one, just as another second paragraph?
Where did I put it?
The last two.
Sorry about that.
28 and 29. Yeah.
Thank you.
Is that a
Thank you.
question, Angelique?
Yeah, you just did it, thank you.
Okay,
I got it, thanks.
all right. Okay, since I've already written on the test pages that I have for 28 and 29, I'm just going to go starting from scratch on it. So number 28 says to give the following properties of this function. And the function is f of x equals x cubed plus 3x squared minus 4x minus 12. And the first thing it asks us for is the domain. And then the second thing it asks for is the range. And then it asks us for the y-intercept. And the x-intercepts. And then it says, is it even or odd and why? First thing we're going to talk about is the domain. And when you talk about the domain, we've said several times now, the only thing that we need to worry about when talking about domain is that zero, that's not allowed. And you can't take, meaning a square root.
So the function that we're looking at There is no division going on here anywhere. So we don't have to worry about that. There are no roots, no radicals in that equation, so we don't have to worry about that. And since those are the only two things we have to worry about, then the domain. And the symbol for that is negative infinity, comma, infinity, with parentheses around. On the test, you accept either of those as an answer, or do you prefer one or the other? Total numbers. Number 24. Those. Because you have division by 0 in both of those. I think that's the only ones that are on that.
Would you just put not real numbers for that? If it's not a real number, you just put non-real numbers for like 25, or how would you?
No. For 25, you're okay. That tells you x can't be 3. So the way you write it is you put parentheses 3, but it doesn't include 3. And then it doesn't include 3. So you just show what you skip it. And actually, if you don't write it in interval notation, if you can just tell me x can't be 3, that's good. I want to know that you know where the problem is. So it doesn't have to be an interval notation. That's not an absolute requirement. Just tell me what the problem is.
So if you, whatever, like it's a fraction,
Mm-hmm.
and it's like x plus 4 with the, and that's in the denominator. Would it be the negative infinity? So it's
Yeah.
basically just the opposite of
What x is either add or subtract. Yeah. If that's all it is. There's another one. If you look at number 24, this cannot be 0. There's going to be more than one number. In that case, it's going to let it be 0. And we had to use the quadratic formula here to figure out that it couldn't be 1 1/2 and it couldn't be negative 1/2. Okay? So it had a lot of restrictions. It could not be 1 1/2.
So if it's a quadratic formula, you have to factor it out.
You can factor it out, but quadratic formula means you use quadratic formula. Everything doesn't factor. Quadratic formula always finds the zeros. Factoring doesn't always work.
So you use the quadratic formula, you just take, like on number 24, you take the lower half of the division, set it equal to 0 and solve.
Mm-hmm. And you use quadratic formula to solve it. Okay? Now, in order to talk about the range of this function, we have to talk about characteristics of even and odd powered functions. The easiest way to look at this one is actually just to go ahead and draw a graph of it on your calculator. Because one of the things that we learned about polynomial functions is that if the highest degree, which is the highest exponent in the function, is an even number, then both of its arms go up or both of them go down. But if its highest power or its degree is an odd number, then one arm goes up and one down, and they never match. And the reason you need to pay attention to that is because if it's an odd degree function, then its domain is also, or its range is also all real numbers. because it'll go down to negative infinity and up to positive infinity one way or the other. It's either going to do it this way or this way. Okay?
Can you repeat that? Wait.
Let me show you the picture.
So if it's the degree is an even number, they both go up or down.
Yes.
Okay.
Picture like this. It's like
Okay. This is going down forever. This is going up forever. So do you see what I mean about its arms? One goes up, one goes down. Okay? Angelique? Okay? That's going to happen for any function that has an odd degree term. I can go back over here and I can change that 3 to a 5. And it's still going to do the same thing. It's going to shift the wiggly part of it around. But it still goes down forever and up forever. Okay?
But if it was like 2, it would
Right.
go up or down.
Yeah, if I delete out that first term and not just use 3x squared minus 4x minus 12, both of them go up. And if I change it by putting a negative sign in front of that 3, then both sides will just go down. Okay? That means they have a range restriction. They either have a top or they have a bottom. The odd degree functions, their range is all real numbers. And I'm putting that back in there because we're going to look at this again. The y-intercept of this function is where it crosses the y-axis. That means its value of x is going to be 0. If x is 0, then this is 0 cubed plus 3 zeros squared minus 4 times 0 minus 12. So knowing that if x is 0, if you plug that in, you know that y is going to be negative 12 just by looking at it. But you can also get your calculator to tell you what it is by graphing it and then going second trace, choose value, and tell it to show me where x is equal to 0, and it'll show you. Okay? You can also find your x-intercepts that way. And it just so happens that this one has 1, 2, 3 x-intercepts. So in order to find your x-intercept, you use that trace menu, and you go down, and the x-intercepts are called zeros. It's basically where y is equal to 0. So you choose 0. You move your cursor until it is just barely to the left of the x-intercept. Hit enter. Move it to where it's just barely to the right of the x-intercept and hit enter. And then hit enter a third time. And it says one of the x-intercepts is negative 3, 0. And then you do the same thing again. Second trace, choose the 0, move it to where it's just barely to the left of the x-intercept, hit enter. Then move on to the right past the x-intercept, hit enter again, and hit enter the third time, and it says the next one is -2, 0. And then you go find the last one. Second trace, down to number 2.
I'm sort of lost on what it is you're doing. I was still at range, where you had the negative infinity and the infinity. And then I don't know what you're doing past there.
Okay, the best thing for you to do is to watch the recording and do it over again. Okay? Because we actually, the recording for 10.3 that we did on Monday night, I went through that several times on Monday night.
Okay.
So there's plenty of that you can go up and watch. But in order to be able to address Gavin's problem, I'm going to need to get done because we've only got 10 minutes left.
I mean, you can help, if you want, if she needs help, you can help her. I can go back and watch the problem. I'm kind of clear on it. I'm sort of clear on it. I just would like to see it one more time. So if she's
No, it's worth the time to go ahead and make sure that you're clear, and it'll help them too, because this will be another recording of it. So we get to the left of it, press enter, move the cursor past it, press enter, and then enter, and it tells you the third x-intercept is 2, 0. And then the last thing that it asks you is the function even or odd or neither. And this is something you're going to have to know. You're going to have to get it straight in your head and probably memorize it. Because this is not a formula that's on the test. A function is even if f of the opposite of x, or in other words, f of negative x, is exactly the same as f of x, the original function. It is odd if f of negative x is equal to the opposite of f of x. In other words, f of x with all of its signs flipped around. And the only way to figure that out is to actually plug in negative x into the function and simplify it. So if this is f of x, then f of negative x simply substitutes negative x every place that you see x. Okay? Just put a negative sign every place that you have an x. Remember that negative x cubed is negative x times negative x times negative x. So that's going to be negative x cubed. Negative x squared, on the other hand, is just going to be x squared, and you're multiplying it by 3. Negative times negative is positive 4x, and nothing happened to the 12 because there was no x in it. So this is f of negative x. So we're going to compare f of negative x to f of x. Is it the same? Nope. Because we have a negative here and a positive there. We have a positive here and a negative there. Or excuse me, there. Now the fact that this matches and this matches doesn't matter because these already don't match. So this is not true. The opposite of f of x just means change all the signs. So there's the opposite of f of x with all of its signs changed. And there again, you're going to compare. Does everything match? Well, negative matches negative, so far so good. Then positive doesn't match negative. Positive matches positive, but negative doesn't match positive. That's not true either then. So that means it's neither. And the why is when you show me this. Okay?
Okay, so you want us to write it all out like that?
Yes. You need to write out what is f of x, what is f of negative x, and then simplify it, and then what is f of x with all of its signs changed. And you're going to have to compare them. And what you're comparing is f of negative x to this one and to this one. And if they don't match perfectly, then it's not that one. It's not even or it's not odd. And that means it's neither. Okay?
Can I see up a little higher on our page? Thank you.
Okay, and the last one that you wanted to see was number 29. Number 29 is about the growth of bacteria in food products. It says, suppose for a certain product that the number of bacteria present is given by this function. The function is f of t, and t represents time. And this is the number of bacteria in millions. So it's 500 e to the 0.01 t million bacteria at t, and t is measured in days. And that's t days after January 1, because it says t sub 0 or t0 corresponds to January 1. And what they want us to do is find the date that we should place on that product. If the food can't be eaten, if the total number of bacteria gets up to be 3,000 million, and take into account million is part of f of t. So you don't use the word million, you only use the number. So you don't put in 300 and then add 6 zeros to it. You just use 3,000 because it's 3,000 million. So we're going to let f of t be 3,000 million, which means f of t's actual numerical value then is 3,000. 3,000 equals 500 e to the 0.1 t. And the first thing you're going to do is solve it as much as you can algebraically. Since this is multiplying times e raised to that power, we're going to divide off that 500.
So 30 over 5 is actually equal to 6. So the equivalent equation then is e raised to the 0.01t would be equal to 6. Now there's two different ways that we can solve this. The algebraic method says we're going to take the natural log of 6, which is just a function on your calculator, is equal to the natural log of e to the 0.1t power. And the reason that we're going to do that is because the natural log of e to that power is just the power. So 0.1t is actually equal to the natural logarithm of 6. And you find the natural logarithm of 6 by pressing the ln key, which is next to the number 4 key. And you get that decimal. And the way to solve this then is divide both sides by 0.1. And we'll have the value of t.
I'm not coming up with the same decimal you came up with.
What did you press?
Just log and then 6.
Log is not the same as the natural log.
So clear. So second log.
No. Next to the number 4, ln. That's the natural log.
Okay.
Okay?
Ms. Lynn,
Thanks.
do you put in the entire decimal, or can
No.
you?
I'm going to just, right now, leave it in the calculator and divide it by 0.01.
Oh,
So I don't have to type it back in. So with that number sitting there, just hit your division symbol and type in your 0.1. And we get 17.9175. And then we have to think about, okay, how can we round this? So we need to go back to what the function actually says. T is the number of days after January 1. So it's 17.9175 days after January 1. So basically, it's going to be January 19th. Wait.
you,
No. It's going to be January 18th. Okay? Because 0 is January 1.
would you round that number, 17.9175,
I would round it up to 18.
18?
Because this tells you that January 17th is almost over when that happens. Okay? Now, then you need to go back and think about what this question says. The question says, what date should be put on the product? The number of bacteria is going to exceed 300,000 on the 18th. So you don't want to put the 18th on it, because the milk, if it's milk, is spoiled then. It's bad. So what you want to put on it is January 17th. That's the last day you should use it. Okay?
So even though January 18th is the day it exceeds, you don't want to put the date that it exceeds on there. You want to put on there the date that it's still safe. Okay? Does anybody have any other questions on that one? Does that make more sense now?
Yes, thank you.
Well, we're out of time.
Northeast is closing at 3 for the weather.
I'm not surprised because my ground was white.
You know, it was
When I
snowing
left
in my
my
house
house
when I woke up.
I didn't have anything done.
So y'all travel safely.
You as well.
Thank you.
Thank you for coming in.
No problem. Glad to do it.
Do you want me to take, because I'm gonna take.
You were a big help.
Yeah, this was a lot of help.
got it.
Do you want me to take you now, because I'm gonna take my final only, and I know I want to take my vehicle. Do you want me to tell you, and I know.
I'd rather you send it to me in text because I can go back to my text and remember. My brain will work for your
I have
office
a
to
whole
remember
month
that.
off.
Okay. I'll show you through it.
I
Thank you, take care. Yeah. Yeah, I live near South Olson Dam. So from my house to here, taking the short route takes about 40 minutes. And it was snowing when I woke up.
Yeah.
Pretty good.
Yeah, it was snowing when I woke up at my house too, and when I went through Jonesboro, the ground was white.
Oh, God.
But then, like, before I ever got to Gray, it all dried up.
I came from Johnson City. I don't live far. I came from Johnson City, and it wasn't a bit. It wasn't even Froyo when I came in.
It was snowing pretty good when I came back to step out and get on the phone.
My car is in the snow. I know this one.